Okay. Hello, everyone. Coming. My name is Mikhail. I'll talk about some robots that play soccer today. Heads up if you've been on this presentation last year. Very good. Okay, the slides are mostly the same. So robots playing soccer. Huh? Most people think that most people don't know robots can play soccer. But people who saw these robots on YouTube sometimes playing soccer think that we sit somewhere in the dark room with game pads controlling, kicking balls. Well, we actually don't. Unfortunately, they will play autonomously. So if they do something bad, we cannot play. Helps with mental health. This is us. Every year we go to a competition. It's a World Cup. It's like FIFA for robotic soccer. And this is our team event this year. You can see some of these people here. And we came third this year and got third all, so we came third in the world on the world stage. We're good for Australia. And because you're all very bright engineers, we actually would like to have you on board as well. So if you want to represent Australia somewhere where Australia wins, please join us. We talked about different skills that we need, but you can join us. You don't have to be a student. I'm not a student. But I'm still part of the team. And so we just talked a little bit about RoboCup, what we do, how they work. We'll also run a demo. You can play with the robot a little bit, punch the ball, and So what's the RoboCup? The goal of the RoboCup is to win against humans in 2050. I think original goal was to win against humans in 2030, but we realized that that's probably not realistic, so we moved it to 2050. I think in 20 years, I'll be staying here, I'll be 27 for the same slides. So we'll see how they go. Actually, one team of the league still keeps the 2030 goal. Win against humans, and but basically not just against humans, not just any humans. You can probably win against humans that don't move. It's difficult, but maybe we can. But win against the FIFA champion team, like the human team who won the world championship. These robots, well, not these robots that working on and robots running our software, they need to win against these very capable human beings. 2050, I think it's possible. But the actual goal is to create more robotics engineers. So you know how some very famous person in aerospace, he wants to go to Mars. Everywhere he goes, he says, we're going to build these rockets to go to Mars. But the actual goal, why they do that, they just want to attract the best engineers in the world to work for them, because it's a great goal. So same with RoboCup. We need more robotics engineers because the world needs more robotics engineers. Because we're lazy, we don't want to do all this work by ourselves. We're just going to be on basic income at some point. The robots need to take over. More robotics engineers, and first started with the dogs, soccer, all the balls, and then the ball was orange, and it was very, very, very easy. But then at some point we got now, made by SoftBank. Oh, this is the platform. So it's a software competition. We are not allowed to change hardware. We can only write better software. Everyone is using exactly the same platform, exactly the same robots. They are not perfect, actually quite bad and unstable, but that's part of the fun. How do you write software that still allows them to win? And the critical skill that this RoboCup is training, not just training some kind of robotics engineers, but trains robotics engineers who can build robots that are resilient, that can work in difficult conditions, some unpredictable environments, very different from robots who work in a factory assembling Teslas, who know by, the hundreds of millimeters precision where they need to put that screw. Like these robots have no idea where they are most of the time, and they still manage to win games. And we'll talk about how they do it. So really, it's about how do we train humans to write resilient software for robots. And yeah, robots wear jerseys. We wear yellow and green because. But then RoboCup kind of exploded at some point. Now there's like logistics because maybe helping Amazon to do all this fulfillment. There's at work robots. If you're lazy at work, maybe there will be robots helping you printing. At home, if you're lazy, you don't want to put your garbage out, they will help you. So there are all sorts of different types of robots. They all happen at the same time in a very, very big warehouse. A lot of teams from hundreds of countries come in and compete. But we only do, and soccer also, there's all sorts of robots that play soccer, but we only do particular ones, the standard platform one. Actually, so if you're mostly interested in like hardware, for example, there are some leagues that allow you to build your own robot and get it to play soccer. But so far, these robots play best. Like in terms of like the quality of the game, I would say standard platform is the best because we can just focus on software. Hardware still breaks, but we can just focus on one thing that helps. And yeah, so if you want to do something like that, please talk to me. And there will be a few more plugs like this during the presentation. So robotic standard platform, it's a standard platform. These robots, maybe at some point there will be a new version, but essentially we write custom software. Actually, that's a bit outdated slide. Now they play 7v7. So it's 14 robots on the field playing against each other with one ball. And there are some different challenges that different teams focus on one of them. Best teams focus on all of them. But basically there's some DNA. What do you need in your robotics team to win against humans at some point? But so far, robots, you want to work fast. The video doesn't work. But the faster you work, if there are two robots and there's a ball, if one of them is working faster, it's like in soccer, it's like human soccer. Whoever runs faster, that gets the ball and goes somewhere with it. Kicking ball, of course, also important. If you don't know if you can't kick it hard enough, then you don't score. But also perception, like something that we see, is this a ball or not? This robot currently doesn't see the ball. Oh, it sees it. I don't know if you can see that. With a red eye. Okay. When it sees the ball, the eye turns red. Doesn't. You can see the further away from robot I take the ball, start blinking. So it means that it doesn't see the ball every frame, only certain frames. At some point, of course, it will no longer see. I'm actually surprised I can see that far. Maybe the carpet is very contrasting. We play on green field. It's actually great to see. That's awesome. Of course, we need to see the lines of the field. And if you know how this don't work. Okay, great. But if you imagine the soccer field, you have rectangles there, you have lines, and they are absolutely symmetrical. So even if you see all the lines, you actually have no idea which side you're on. And in soccer, unfortunately, it's very important to know which side you're on. Because if you see the goal, you're going to score. But is it your goal or is it the opponent's goal? You don't know. And yes, people do score in their own goal. Because of that problem, just flipping the orientation of the position. Every time we look at the field, we see some lines and we try to understand based on that line where we are, trying to build this kind of mental map of the field. Actually, human players do the same thing, we just kind of don't think about it. Yeah, like determining if you just look at the line, you actually have no idea which line it is. You need to have a more robust system that remembers some things from the past, relies on multiple ways to determine where you are. Not just vision, some memory, So if you knew where you were 5 minutes ago and you knew how you moved there from there, then by using some Kalman filter or some other techniques, you can figure out where you are.
Just on the side with the referee, you mentioned the referee. When you play this game, is there rules? Like, as in, do you get penalised for tripping, or is it just like a Blood Bowl style, robots going to just get the ball in?
Great question. So these rules, the rule book is like that thick. Most rules are based on human soccer. So robots do get penalized if they push another robot too hard, if they fell down and couldn't get up quick enough, they get penalized. If they moved when they're not supposed to move, they get penalized. If they walk off the field, they get penalized. Basically, they get penalized a lot. And the more they penalized, the time of the penalty is basically the robot is being removed from the field. But the game goes on. So if you have if you're playing with 7 robots and all of them penalized, then that's it. Your opponent is playing against an empty field. And yeah, it's kind of like hockey, I guess, in that sense. More like but there's a referee that makes a call. A referee is human, and they make mistakes, of course. And there are this main referee who oversees the game and gives commands, and there is another person who sits at the computer and presses buttons to basically translates from what referee is saying into button clicks that then transform into network packets that go to robots and tell them what is happening. So if the robot is penalized, they need to know they're penalized. Because if you try to pick it up, it will fight you because it wants to stay in the game, it wants to keep playing. If it doesn't know they're penalized, fingers get jammed. It's not pretty. Yeah, so, and of course, robot playing, there could be some questionable situation, fouls with the penalty kick. So, for example, in our games, we had a situation where there was a penalty kick against us. So, thankfully, everyone now watched soccer recently, so you kind of know what penalty is. Yeah, so these things are pretty close to normal soccer. Some things we don't have, like offsides and some other things. But yeah, we still have corner kicks, we still have outs. So pretty close to the normal game. Yeah, and we also play on battery. So if you run out of battery, then yeah, you just have one robot less. Nobody allows you to charge battery to the game. And that means you need to be clever how your software uses the joins. The more you use the joins, the more battery you use. So maybe it's beneficial to not move at some point. It's beneficial to look at the temperature of your joints because they get heat up, they warm up, and at some point they stop moving to the full range, so they can't go all the way 180. They can only go like 60 degrees in between, and that's of course affects whatever you do because it's very difficult to walk if you can't bend your knees, for example. And they still try, and of course they try, they fail, and they get penalized. So how you write your code in a way that would predict the situations and trying to avoid it as well. And yeah, one of the things that is interesting, there is a crowd, there's spectators that are watching, and as all of the teams that participate in RoboCup, we need to find ways how to make it entertaining and interesting, because maybe at some point we need to start selling tickets. These events, we do sell things, but they cost like $10. Maybe at some point it becomes really, really popular, and the only way to do that is to make it more entertaining, get more people in. And there is some things we can do with the other team, but because it's mostly robots playing, we can't really demoralize them. We can demoralize the team captain or the opposite team, or yell at the referee maybe sometimes, but that's it. But of course, strategy is also important, because even if you have a perfect functioning robot, it always knows where it is. It always knows how to pick the ball, get the ball, seize the ball. You still need to figure out what's your strategy. How do you want to play? How do you want to begin the initial kickoff? based on what's the current score. Do you want to be more going on offensive, or do you want to keep defending your goal? You can also need to be ready for some unexpected situations, like maybe how to take advantage of a lot of opponents' team being penalized. So how do you recognize really quickly that you're playing 7 against 3, and so because you now have that advantage, you can maybe pass the ball around them and quickly win. So that strategy is something that we're constantly trying to improve. And all of these things, they actually stack up. So the better you see, the more you understand about where you are, the better decisions you can make as a robot. So improvement in one layer of that software leads to improvements in other layers. So basically, currently we have a lot of layers that need improvement. So please come and talk to me.
How are the robots controlled? Is it self-contained within each robot, or is it that there's a controller or the captain? Or you were saying about influencing the captain who is a person, so what's the mechanism there?
Yes, so robots are autonomous. We do not control them. We are not allowed to communicate to them during the game. It's closely monitored. So they make their decisions by themselves. They talk to each other. They are allowed to exchange messages. These messages are limited. You have a budget of how many messages you're allowed to send. So you also need to be clever about that. You can't just broadcast absolutely everything to everyone. And the size of these messages is also limited. And every year, the number of messages you're allowed to send and the size of these messages is going down. Initially, the goal is to get the robots to play without communicating over network at all. It's making decisions based on what they understand from what they see on the field. The only thing that we can affect, we can ask for robot to pick up a robot. That's the only thing that team captain can do. They can say, can I pick up the yellow one, this robot, and bring it to me? And you can only do it in certain circumstances when you see that maybe there's a hardware issue with the robot, maybe it couldn't move joints, or there's some kind of other issue. Maybe there's a Python error, and you know it's a Python error because you know your robots, and you know they shouldn't behave this way, and you try to pick it up and reboot it and put it back to field. But of course, during that time, you will be less on robots. So you need to. That's the only decision that you can make as a team captain. That's the only human input into this game. Of course, there's human referees, but as a team, that's the only input. So our code that we wrote before the game, that we're not allowed to change during the game. And also team captain can call a timeout. If something goes terribly wrong, we can call 5-minute timeout and do something with robots during that time. That's about it. That's pretty much all control we have. So that's why we need to really program them in a way that they should be able to play. Sometimes cameras stop working. Maybe they hit the floor too hard, and certain robots just can't see anymore. And it's good to know how to determine that from afar and pick it up. Otherwise, it would be very useless.
So the code is running inside the robot.
Yes.
So I presume there's some sort of processor, and you have to compile your code down to some sort of architecture.
Yeah, so it's just normal Linux. It runs Linux. It's like a laptop, essentially.
Okay.
It runs Linux. It has cameras. It has different type of sensors that you can access through some kind of programmatic API. And you can use that API to move joints, but essentially it's a computer with legs and arms.
Beautiful. Okay, cool.
Yeah, so that's just, software written in C++, Python, whatever. Loaded there and stays there, and during the game they just play with what they have. And of course they need to know a little bit about who they are. So for example, a robot that stands in the goal, the goalie, needs to behave a bit differently because they are allowed to do things that other robots are not. So slight changes in behavior. Robots can be, depending on the situation, for example, our robots determine if they want to be attackers or they want to be defenders, depending on how many robots in total, where they are, and they kind of change this behavior. And they change different, in the same situation, they will react differently based on what happens. And all these things need to be programmed.
So if the robot is timeout, can you change the programming on that one, or you can't do it?
Yeah, during the timeout and when so there's 2 halves in the game. So after first half, we can change.
Are you allowed to interfere the opponent robots, like stand in front of him so that you don't see anything?
No, the team is not allowed on the field. So
No, I mean, put your robot in front of others' robot so that the opponent doesn't see anything through the cameras.
I mean, you can program a robot to do that. I mean, we need to read the rules to what extent it would be. Our robots need to move. If they can't be absolutely stationary, if they're not, if they're absolutely standing still, then it's a penalty. So yeah, but if you kind of like just stand around and move a little bit and just don't let them see anything, that's a strategy. So if you know where the ball is, you can just stand in front of the ball and let your team take the ball somewhere, and you just sort of just walk back and forth to make sure they don't see the ball. Yeah, totally. And robots, they're quite aggressively trying to get the ball from each other. So they bump into each other, they try to avoid each other, get the arms back, and they try to like get the ball out. Yeah, so there are certain things you can do. I mean, nothing stops you from just getting like a wall of robot that just moves forward and tries to crush everyone.
Has anyone actually tried that?
We tried to do that this year because it's really difficult to win. But we tried to figure out not this particular maneuver, but some clever initial positions against the other team. So we can choose where robots will be on the field during the initial kickoff, and we try to figure out what's the ideal positioning against that particular team. Because we watch their games, we know what they do in the beginning, and so we try to not let them do that, basically. So, for example, if we know that the team always starts by trying to kick the ball from the middle to the goal, we would put the robots strategically in front of them so they can't do that. But if we're playing against the other team, we might choose a different setup, different tactic. So we have to change the code from game to game. I mean, ideally we should. It's just very difficult because the competition is very, very demanding. Usually it's 3 games during the day, and we are a small team, and we just barely have enough time to set up for the game. We don't have that redundancy in the team that would allow someone to just focus on coding for the next game and someone else to do the logistics. We can only afford at the moment to send about 4 people. It's expensive, we will pay for that ourselves. And yeah, if we find more sponsors or more people in the team who are willing to go and pay for tickets, then it will be easier. Or even there's some people staying usually and they work on the code, so that helps. That was really helpful this year, actually. Yeah. Expected circumstances. I'll just talk about just generally how the architecture works. So we have a couple of sensors. We have IMU. We have microphones, different joints, and different sensors on the feet to determine how well we're pressing against the floor. We take pictures from cameras, and these pictures then go to the vision pipeline. We try to detect field features, corners, crosses, circles, and from there then determine where we are. We want to detect different robots so that we can avoid them. We want to know, of course, where the ball is. And it all, we create this kind of sensory compilation of what the robot knows. At 30 times per second, we create that snapshot of everything that we know about the world. And this is, and at 30 times per second, we make decisions. What are we going to do about this situation? And yeah, of course, we need to at some point know where we are. We need to also listen to other teammates. They do communicate to us. And all of that goes to some kind of high level logic where we do the strategy. Like now knowing where we are, where the ball is, where our teammates are, which strategy are we going to implement? And the strategies are behavior trees, decision trees. For those who don't know what behavior trees are. And we have these different skills. So let's say we have a skill to find the ball. We have a skill to dribble the ball around the robot. We have a skill to kick the ball. We have a skill to maybe support other team members. And team members can ask for help, and we can go there and help them. It's maybe 50 skills, 50 skills. There's a lot of them. And it's good about this architecture that some person who joins the team, they can work on one particular small skill to begin with, and it's contained in just one file. Just make changes to one file, and by changing that one file, you actually can make a significant contribution to the result.
How often is the hardware again? Big stack. How much is model on that?
When was the V5?
So I think V6 just came out in 2016 or something like that, probably earlier. I think it's usually like 5, greater than 5. I think SoftBank is currently designing a V7, but maybe next 2 years or something.
Just to get an idea of how much processing ability these have, compared to a Raspberry Pi, is it as computationally powerful, less, more? Significantly more?
Was it AMD64 something?
Bigger processor? I would say it's much less than a Raspberry Pi, or probably about the right person.
Okay.
It's from 2016 or earlier. So it's from like a Chromebook or that kind of.
Gotcha. Is it like an ARM Cortex or something?
It's not an ARM. I think it was an Intel. I can't remember the exact model.
It doesn't matter.
I think it's 64-bit something processor.
Oh yeah,
86 actually.
Okay.
It's an Intel Atom E3845.
yeah.
It's a standard.
Are you allowed to hack it?
I don't know. I feel like my Raspberry Pi can't process images as fast as Robert, but yeah. Anyway, it's debatable.
Are these robots commercially available?
Yeah.
How much do they cost out?
Well,
Too much.
okay.
12K. Okay.
How much did you pay for yours?
Oh, 16,000. 16, yeah, 16,000.
Okay. All right.
We have a discount. Yeah, they're quite expensive. We try not to break
by a
them.
lot.
So there's 200K of $200,000 of equipment on time.
Yeah.
Okay.
Yeah.
All right.
Yeah.
Don't kick it. I was just wondering whether you keep a video clip
Sorry?
of your robots playing.
Sorry, come again?
Have you got a video clip of your robots playing the game?
Yeah, I'll show it. And we actually, I'll show the demo. We'll probably show one of the recent games. You actually, if you can find it and send me a link on Discord in the meantime. Some good, maybe a good moment from the game or something.
Oh yeah.
We can show it. Yeah, of course, skills then determine what we're going to do. And then we send, okay, this joint goes this way, this joint goes this way. So if you want to, and of course, we want to use machine learning more. So right now, it's very much classical computer vision stuff. So line detection, line segmentation, all of that written, most of the vision pipeline has been written like ages ago. And this year, we want to do more machine learning. Starting from simple things like detecting if we see a robot, what color of the jersey they're wearing, to see if it's our robot or not our. Something Peter is working on right now. But we want to eventually maybe do the whole vision pipeline end-to-end machine. That we need a lot of simulation to train on. These robots are very expensive. We can't run them like for a very long time on the field. and of course, there's battery and all the other limitations. So ideally, we would like to train it first on some kind of 500 server somewhere in the cloud. If only there was a cloud. About that.
Talking to the right guy here.
But
This jersey detection problem I know is hard because I was playing out futsal on Monday, and our team was wearing pink and the other team was wearing orange. And one of our guys was wearing a sort of a dark pink shirt, and I just thought there was two of our guys here. I'm just throwing it in directly to the opponent, and just because I couldn't tell the difference between pink and orange. So to get like humans make these mistakes,
yeah,
at least I do.
we were also fortunate that this year they introduced different color jerseys for goalies. So goalies need to have different colors, and we went with green, yellow and green, Australia, and the other team couldn't see that because green is the color of the field. Very, very long time, I think green was not allowed as a jersey, and so yeah, they couldn't see the goalie. It's really useful on a penalty shootout because they were just kicking straight.
Are you allowed to decentralize the processing power of to the cloud base
During the game,
during the game, like maybe like something?
not allowed to access internet or anything else. Only allowed to talk to each other, and only I think it's 1,000 packets, something like that, 1,200 packets for 20 minutes. And these packets are 20 bytes. So not many things you can squeeze in, unfortunately. Yeah, that would be completely different game. But what we could do, we could have an accurate simulation of the game and train behaviors in simulation, and then deploy it to the robots. So use some reinforcement learning, for example, just run them for 25,000 years in simulated environment on thousands of servers, and then use that machine learning model that we get as a result to deploy it to the robot. Use that. That's one application. But broadly, those who kind of know me know that I don't work for robotic soccer. I build robots for space, and this is what we do: robots that repair satellites. But the reason I do this is because all the same problems that these guys have with robot soccer are actually the same problems that we try to deal with when we try to repair satellites. We still need to figure out where the satellite is, how to accurately move our arm to grab that satellite, where we are, have some kind of high-level logic about it, because we can't control satellite from here, can't control our robot all the way to orbit. We don't have that bandwidth. There's also a thing called speed of light, unfortunately, gets in the way. So all of these skills that these bright people develop during their RoboCup experience is what we need as well as a company. So that's why we're proud to sponsor them. And that's why everyone should also consider talking to your boss about sponsoring us as well. Please do send people to competitions. We also need to build better tools and instruments to analyze the games. So for example, if you're doing some web development, please join us. Recently we wrote all our tools to web-based, so now we can run all the tooling on any computer and even an iPhone because it's web app. And that web app can connect to a robot and allow you to do a lot of calibrations with the robot. Because during the competition, you have different lighting conditions in different fields. You need to set up different camera settings. Yeah, there's a lot of things that you need to, when you come to the venue. Maybe the grass is 1 millimeter taller than your lab, or maybe 1 centimeter taller. Sometimes the lines are not painted really well. So we always need to adjust when we come to the competition. The first 2 days we spent on a setup, just basically reconfiguring everything just to make sure we can still play on these fields. That's a bit of a challenge. As you can see, there's a big difference. This is our lab, this is the color of the grass, and this is the competition. Very different lines. We have very nice painted lines, and the competition usually use spray paint. That's why we need certain calibration. This is is what the robot sees. I'll probably show it later. Yeah, a lot of calibration that we need to do, like I just did, like with the ball, just moving it around, just making sure it still can see it. And yeah, so last year we came third. And this year we came third. You can see the leaderboard doesn't change very much. Something else you can see that actually 4 out of 5 teams are from Germany. And you know why? Because they have more than one team in Germany. Yeah, and they compete with each other often. While we just recently got a new team in Melbourne, so compete with them. So hopefully we'll get us a bit higher. But yeah, the team on the first only missed 1 goal in like 5 years. And they usually win 10-0. So they're like very good. We have a great aspiration to beat them. And yeah, we need more Australian teams. Maybe some of you can start a team. And if you know some of that, please talk to me, especially this. Be nice, those marketing. And yeah, you can join us for RoboCup 2024. We're going to Eindhoven, it's in Netherlands. So you can do a Euro trip and also, yeah.
You've had a RoboCup, you get to meet the teams, I imagine. Do you get to collaborate with them, or do they share some of the, what's the secret sauce? Why do they really, is their code radically different or approach radically different, do you think? At least at a higher level?
Well, first of all, it's a very collaborative community. Everyone is super friendly. People come to RoboCup. Most of them have been doing RoboCup for like 10 years. They know everyone. They're best friends. They're looking forward to RoboCup. Yeah, it's a really nice community. And people give us pointers. Maybe they had something during the game and they come to us and say, hey, we noticed you do this. We also had this problem. You know, this is how we solved it. Also, all code is open sourced after the competition. Well, I would say most of the code is open sourced. Everything except strategy is open sourced. So vision, localization, how to move the joins, open source. If we look at the current team, so new teams, they usually pick one of the code bases and branch off. I think most of the teams actually branched off either rUNSWift or rhuman. Actually, rhuman also branched off rUNSWift at some point. They took the walk, but now they're much better. Yeah, and there are some teams who started very long time ago, and they still have their own frameworks, but most of them start somewhere because it's really hard to write something from scratch and show up to the competition. It takes enormous effort. I think, yeah, this has been going for like 12 years maybe. So, yeah. But there are teams who took the code from rhuman from the first top 1 team, but they still couldn't beat them because of strategy level is so important. At least they don't have issues with vision. Yeah, this is the way to join. You can scan this. This is the Discord. We use Discord as a main tool of working and communication. Also, I'm going to show you some things. So this is the tool that we just wrote this year. This allows us to test various aspects of the robot. Previously, it was a C++ application that stopped working. So we needed a new tool, and this is just built in React. So any of you knows React? Help us with that. So with this thing, what we can do is we can debug what the robot can see. So there are not many lines here, so we won't be able to see much of that. But basically, everything that's blue, it thinks it's a line, and then it tries to combine these regions together to build bigger lines and bigger features out of that. It sees the ball here. Yeah, it's red. This is how we test things, and we can change some of the settings in real time, and we can tweak. Maybe we show up for competition and it doesn't see the ball at all. That happens, and then we change something, and then start seeing the ball. We tweak, and because the different fields will have different lighting conditions, we have to have different camera settings. This tool helps a lot to do that. Previously, so now we can just move the slider and change the camera settings in real time. Previously, last year in Thailand, we had to change it in a file, reboot the robot, and see if that works. So changing the setting took us 2 minutes. Now it takes 1 second. So the tools are really important.
So, the camera is seen in black and white, 2 colors. That's all this camera is seeing.
Okay. So camera is actually seeing normal. This is post-processing. So we take the normal picture and then we binarize it. So we look at things that look like something that looks whitish. We just say it's a white pixel. Something that doesn't look whitish, we just say it's black. And we get that very compressed representation. And with that representation, it's very easy to then determine where things are. But in reality, yeah.
And is the flickering due to the fluorescent lights? Or is that something else going on?
Sorry, the question was the flicker.
Is that due to the fluorescent
It
lights?
looks like it is, yeah.
Yeah, that could be it, actually. Sure. So this is the raw image, but as you can see, the frame rate on the raw image is much less.
It's not a very good camera, though, is it? Not a very good camera, though. Like, the contrast is...
Yeah, that's something that we said. So it's not very good for the human, but it's good for robot. Because when you want for this to work well, like the binaurization, joining things to either white or black, you want very high contrast, but you also want darker. So we just discovered that the darker the image is kind of easier to see for some reason. But it also depends on the threshold, like how white things need to be to become a white pixel versus black pixel as well. This threshold might.
And who produces these robots? Like, is it like one company or is it just like standard that is produced by multiple companies?
Yeah, it's just one company produces these robots.
And are there plans to like release the constraint and every team brings their own robot in the future?
There are different leagues of robotic soccer, and some of them are using their own robots that they built. They have, I think they still have some kind of constraints, but they can change how the joints work. They can innovate both mechanically and on software. Whereas we play in this league, and only these robots, everyone has the same robot. I think there are pros and cons. I think it's more fun, of course, to work on mechanical stuff and also on software. But if you think about it, the teams who have more money can afford lighter motors that have better torque, and teams who have less money will not be able to afford better mechanical parts. So someone can afford aviation grade aluminum or something, or carbon fibers. Someone has to do plastic or steel, and of course that will affect the performance in the game. So it's more about money competition. But if it's software only, if the team is can afford to buy 6-7 robots and then yeah, it's only as good as your software. It doesn't really matter. Because money do play a role. That's why we're always looking for sponsors. But at least it's a little bit more fair.
I think the one without constraint is called Robot Walls.
Yeah, we can just maybe run a short demo. Do you want to do that?
Sorry, I'm sure.